Hi everyone, my name is Jelle Laverge. I'm an associate professor at Ghent University, and I'll be speaking about ventilation and indoor air quality in bedrooms. More specifically, I want to show some examples of what we know about what indoor air quality in real bedrooms actually is. Then go a little bit into how that level of indoor air quality is affected by ventilation, and then end up and kind of make a bridge to the next presentation, which is by Pavel, on how can we what are relevant metrics for indoor air quality and ventilation in bedrooms, based on what we see actually happens in bedrooms, and what is the knowledge that is still lacking to really define those metrics. So first of all, what is indoor air quality in bedrooms? I'll just show results from different studies that to give you kind of a overview picture. So this is from a relatively recent study that we were involved in, where we measured indoor air quality and different parameters in a number of homes in Denmark. And the results are fairly typical for what we see in bedrooms in a European context, namely that there's relatively high CO2 concentrations. Let me just try to bring up a laser pointer. Okay. All right, so relatively high CO2 concentrations, relatively low air change rates in bedrooms, but in terms of other pollutants, not that much things to worry about. So things like NO2, VOCs, PM, or generally what we see in other indoor environments, not so often close or above relevant threshold values. Also, what we see is that if we look at complaints about IEQ in bedrooms, that the most found complaints are related to too warm indoor climate and noise in the climate in the bedroom. Much fewer complaints about too cold environment, and also actually not that much complaints about stuffy air or bad indoor air quality in bedrooms compared to too high temperatures and noise. Also, in terms of pollutants, we see that there's a quite consistent, what we would expect, of course, relationship between CO2 concentration, which is the last column here, and ventilation rates. But we don't see a very consistent correlation between CO2 and other pollutants in the bedroom, which means that there's a variety of potential sources that play a role in a bedroom, and they differ from bedroom to bedroom, so that there's not a very consistent type of or pattern of indoor air quality in a bedroom that we can point to, other than the fact that we typically see relatively elevated CO2 levels. Related to the question that came up during the Q&A just now, regarding where to measure and what the exposure level is. These are some results from a bit of older research that I was involved in the 2010s, that showed that actually the exposure of the actual sleeping people to pollutants that have sources in their direct environment, this was related to emissions from mattresses, bedding, and things like that, is elevated compared to the concentration in the bulk of the room, and this elevation is quite consistent between 20 and 70% for a mattress source, depending on the way you are sleeping with your head towards the mattress. So in a prone position will give you a higher elevation than if you sleep in a lateral position or on your back, which then gives you about 20 or 40% higher concentration. Also, the arrangement of the bedding can have a huge impact. So typically we have between 1 and 1.5 as a ratio between the concentration in the bulk airflow and in the breathing zone of the person. But if this person sleeps with the blankets over the head, which surprisingly lots of people do, this ratio can increase to more than 30. So the actual exposure can be very high to local sources of VOCs because of the arrangement of the bedding. So the exposure can also be high and the potential consequences can be high. Other thing that we typically see is that although temperature and relative humidity conditions are typically quite stable during the night, which is what you see on the two right figures, the CO2 builds up. This was also already shown in Chandra's presentation, and so we see higher levels of CO2 at the end of the night than in the beginning of the night. And this also translates into the perception of the people. So they report worse odor, worse perceived indoor air quality, which is what you see here at the end of the night. And we also see this in measurements. This is what you can see here on the right, steadily rising CO2 concentration. And contrary to what you would typically expect, we typically don't reach steady state during the night. The concentration keeps building. Also, what you can see from this graph is that in terms of CO2, the exposure is typically much higher in the bedrooms during the night, of course, which is this part of the graph, compared to the exposure to CO2 in other rooms in the dwelling. So in terms of not enough ventilation, as Pavel just said, the conditions in the bedroom are actually suboptimal. Okay, so what does this mean for the ventilation strategy? Well, if we ventilate, we will typically have a relatively large effect on the CO2 concentration. This is what you can see here. So if you open windows or the door, the CO2 concentration is typically much lower, and you get a larger air exchange rate in the bedroom. But this does not directly translate to a similar effect on all other pollutants. For example, in those same conditions, we saw a very small effect only on the mean VOC concentration, and the same for PM and NO2 concentrations. NO2 concentrations even went up because the main source for the NO2 was from outdoors. So in terms of ventilation, we see a reduced effect. We see a reduction of the CO2. CO2 is typically one of the indicators for perceived air quality. And so we also see this effect with increased ventilation, in this case, by using mechanical ventilation. We see a reduction of disturbances due to complaints of stuffy air. And we also see an improvement of the thermal environment, so less complaints about a too cool environment. However, remember that those two complaints were the least amount of complaints that we typically see in bedrooms, and we typically have more complaints about too high temperatures and noise. Okay, so how does all of this translate into how we can think about relevant metrics for indoor air quality and ventilation in bedrooms? Well, first thing is that if we think about health, one of the important takeaways is that we need to take into account the exposure of the sleeping person very locally, even in the bed. So measuring in near the bed is probably also still not enough, especially if the person is sleeping under cover. So we need to take into account the real exposure to specific pollutants, such as VOCs that have local sources in the bedroom. And then if we think about a broader scope, health and well-being, we typically think about impact on sleep, and this has multiple dimensions. First one is how important is perceived air quality. Most of the ventilation standards are based on CO2 as a marker or air change rate as a marker for perceived air quality. Of course, when you're sleeping, what is the effect of perceived air quality? This is something that we try to look at in some studies that Pavel will also talk about more in the next presentation. But one of the results there is that there's potentially an indirect connection, namely, if there's more ventilation, we see less complaints about stuffy air, and less complaints about stuffy air leads to less sleep disturbance, so a somewhat improved sleep quality. But we don't really find good evidence for a direct link so far. So this is certainly something that needs to be looked at. Then this leads to the next point. An important part of sleep quality is avoiding disturbances, because disturbances will wake you up and bring you to light sleep, and all of the things that were mentioned by Lilan and Pavel earlier. And so this is also a result that came out of these studies. If there are more disturbances, the perception of sleep quality also gets worse. So one of the relevant metrics seems to be avoiding disturbances. And so we try to implement that idea into a framework where we try to monetize all of the IAQ costs or IAQ impacts in buildings. And so we tried to work on, this is work done by a postdoc in our team, Louis Conny, where he tried to identify reasons or conditions that would have a high probability of leading to disturbances, summing all of these up into a probability of having a disturbance, and then associate a cost to the occurrence of disturbances in sleep. This is a framework that we propose and that we will try to work on further to take into account sleep quality in terms of avoiding disturbances. And then I think the most difficult part, and that is what Pavel will talk about more, is how can we improve sleep quality in healthy subjects? Is it doable by tweaking the bedroom environment? And there, as was already mentioned by Lilan and Pavel, we try to work towards data that relates environmental parameters such as CO2 concentration as a marker of ventilation, for example, to specific sleep conditions, sleep parameters, so here, for example, the percentage of deep sleep or the time of deep sleep. And if we are able to show a relationship like this, this is a very tentative one based on that really needs to be explored more, but I want to use it as an example. You can then, through doing Bayesian analysis, try to find the potential impact that this relationship has. And for example, here we can see that we can change on average the deep sleep, or there's a suggestion that you could change the percentage of deep sleep by 3% by reducing the CO2 concentration. And then if we compare that to the appropriate ranges of different sleep parameters, such as sleep efficiency, deep sleep, and so forth, we can estimate if this effect is meaningful or not, and try to use that as a basis for further development of criteria. But this is something that really needs to be done in the future. And this brings me to the last part of what I want to share with you, which is what actually do we still need to be able to move forward? And in my opinion, what we don't have yet to make these last few steps that I mentioned is good conclusive data that supports robust assumptions on correlations between environmental factors and sleep parameters. So both for disturbances, but certainly for appropriate sleep quality and normal sleep. We also need good conclusive data on the long-term effects of moderately reduced or improved sleep quality on healthy people. We really don't know. We have some suggestions on the direct effect between environmental parameters and some of the sleep parameters, but we really don't have a good model that then projects that into the long-term effects. And all of this needs to come together into a mechanistic slash physiological model to understand the observed correlations from experiments. And with that, I would like to hand over to Pavel, who wants to address exactly that in his presentation.